Composition of functions. Composition of function is not multiplying two functions together. It's inputting one function into the other. So now right here, I'm given two functions. I'm given f of x and I'm given g of x. And it's asking me to find the domain of f of g of x. So the first thing I'm going to do is I'm going to take f of g of x. And the input right here is going to be my g of x. So I'm going to replace g of x with what it's equal to, which is this. And now here, I am going to input this for every x I see in f of x. So here, this is the only x place I see. So instead of this x place, I am just going to put the function 2 over x minus 1, and now plus 3. A lot of students, they simplify the function to find their domain. You will be doing that. However, before doing that, you need to find the restriction of g of x, of your input function, which here happens to be g of x. So now if I look at g of x by itself, which is 2 over x minus 1, whenever you have a rational function or a function that looks like a fraction, denominator cannot equal 0. Even if you put it into the calculator, whenever you do 2 over 0, it gives you domain error. So the first thing we're going to do is we're going to take the denominator of g of x, which is x minus 1, and we're going to solve when that function is 0. So adding 1 to both sides gives you x is equal to 1. So here, my first restriction is x cannot equal to 1. After you find the restriction of your input function, now we're going to work on simplifying the function. So now here, I have 1. I'm just going to work on the denominator. Again, in order for me to combine two fractions, because this is technically 3 over 1, I need to have the same denominators. So 2 over x minus 1, I'm not going to do anything with it. However, plus 3 over 1, I am going to multiply top and bottom by x minus 1. This will give me 1. Notice I haven't done anything to the numerator. All of the work is done on the bottom. X minus 1 plus 3 times this. I honestly like to leave it in this form. I'm not going to combine it, over x minus 1. Now notice I have the same denominators. Now I can add the top. So that gives me 1 over 2 plus 3x minus 1 all over x minus 1. Now I'm going to get rid of this parentheses by multiplying it. So that gives me 2. Now some students, they say, can't we just eliminate this x minus 1 with this x minus 1? No, you cannot do that because there is an addition right here. Something is being added, and this right here, the first number, does not have x minus 1. So you cannot eliminate this x minus 1 with this. So that's 2 plus 3x minus 3 all over x minus 1. Combine like terms. 2 minus 3 gives you 2x minus 1 over x minus 1. And now here another important thing. Whenever you have a fraction looking form, so for instance, a over b divided by c over d, that is the same as the first fraction in the numerator stays the same times the reciprocal of the bottom, d over c. So this is how you divide rational functions. And that's what I'm going to do right here. Yes, it's 3x minus 1. So now here the numerator, which is 1, and I am going to multiply by the reciprocal of the denominator, which is x minus 1 over 3x minus 1. So that is equal to x minus 1 over 3x minus 1. So this is my simplified composition function. So f of g of x is equal to x minus 1, 3x minus 1. Now I have a rational function again for a function that looks like a fraction. I cannot have a 0 in the denominator. So I'm going to take my denominator, which is 3x minus 1, and find the value that would make that a 0. So add 1 to both sides. Gives you 3x not equal to 1. Divide by 3. So x cannot equal to 1/3. Now these are both of my values, which I am going to work with to find my domain. To write the domain of our function, domain of f of g of x, which I need it in interval notation, it's going to be all the values from negative infinity up to 1/3, union all the values between 1/3, comma 1, union all the values from 1 to infinity. So any value, any input value on a number line works except for 1/3 and 1.